everyone, myself Dr. M. Lakshmi Prasad, working as an associate professor in the Department of Data Science, Institute of Aeronautical Engineering, Hyderabad. In this video, I am going to discuss about introduction part of graphical presentation of data. So in this video, I am going to cover about the introduction of data presentation, purpose of that one, and various types of presentation, what we call as circular pie diagram, bar diagram, comparative bar diagram, histogram, frequency polygon, and cumulative frequency curve, and conclusion you can able to see. So when it comes to graphical representation of data, so graphical representation is the visual display of the data, and then which is going to have statistical results. So which is going to be more often and effective than presenting the data in tabular form. So there are different types of graphical presentation which is going to be used that depends on the nature and the nature of statistical result. So graphical presentation, so where normally the data what I'm getting should be in the form of text here. So this text is going to be represented in the form of a table. So but understanding it should be of in the forms of rows and columns. And once this table is difficult to analyzing the data what is there in this one, so in order to avoid that we have to show in the form of a representation of data which is going to be analyzing very easily. So this thing of presentation data should be preferred. So the graphical representation which is going to be show like a visual display of the data, and it should be more effective than presenting the data in tabular form. There are different types of data as well, which is going to be used depending upon nature and the statistical. So the purpose of this one data presentation should be which is able to compare the categorical data, and then which can also compare the series of data over the time, and the percentage of total comparisons, and relationship between the two variables, and relationship between the three variables. So the main purpose of the categorical the purpose of data presentation means we can able to compare the categorical data which can provide better understanding, and it can also be compare the series of data over the time. So over the time changes, the data is going to obviously change. Suppose if I'm going to take the temperature part, and the relationship between the data should also be done, and the relation between the three variables also done, and the percentage comparison should also be done. So these are some of the advantages of data presentation. So there are many types of graphical presentation what we're going to have, like circular pie diagram or bar diagram, and comparative bar diagram, histogram, frequency polygon, and frequency cumulative bar. So this one is going to be used when I'm going to represent the data in the form of percentages. So if I'm going to represent the data in percentage view, then I have to go for the circular bar diagram. Circular pie diagram. So the bar diagram, so we are able to represent the form of bars, and they should be of different types like simple bar, multiple bar, composite bar, like this. So simple bar we are able to only maintain single bars itself, and for multiple bar, for single attribute I can able to show the two different values, and composite bar means we are able to divide this into different sections of each bar. And comparative bar diagram is the thing. Histogram, so histogram is going to be used where this histogram is nothing but representing the bars without any gaps between them, and joining the midpoints of all this what we call as histogram. And frequency polygon, so only after eliminating this, the curve what we obtain, that should be the frequency polygon, and cumulative frequency curve which is going to be calculated based on relative frequencies. So let's see one by one. So circular pie diagram. So the pie chart is going to be displays the data in the form of percentage as a whole, and each pie section should have a label percentage, and a total number should be included here. So it's the seeing example. So I'm going to take a number of students in each subject. I'm going to be passed in each subject. I want to show it. So for that the fine. So initially I'm going to have science. So 500 people, and for arts 300 people, for English 250 people registered, maths 100 people, commerce 150 people, and medicine 100 people. Like this, ensure I'm going to have a table. So once the table is there, then I have to convert into the form of pie diagram. So by making a circle, by making use of the protractor, so find out the angle, how much percentage, and can able to obtain the pie diagram. So normally this pie diagram should have a label and then percentage normally for we're going to use it. So what are the advantages of this one? So should be visually appealing and summarize the data into visual form, and be visually simple than other types of graph, and should also shows the percentage of total of each category. So the advantages means visual appealing should be done, and it can also summarize the large data set into visual form, and by seeing the visually, so it should be also simple looking than other types of graphs. It should also be shows the percentage of total for each category. When it comes to disadvantage, so no exact numerical data is there is a disadvantage, and then harder to compare two data sets at a time by the pie diagram, and total unknown unless specified, and use only with the discrete data. These are the disadvantages of this pie diagram. The next one is the bar diagram. So here the bar diagram is commonly used to show the number of proportion of nominal and ordinal data which is going to possess the particular attribute, and then they can able to depict the frequency of each category of the point as the bar rising vertically from the horizontal axis. So the bar graph is commonly used, which is going to show the proportion of nominal ordinal data, and which can also depict the frequency of each category of data rising vertically from the horizontal axis. So the bar diagram. So if you look at this, so this is the table what I'm going to have, and for division 1 I can 20%, for division 30 like this, 15 fail and result of it. So for this type of situations, for this kind of applications, so normally we're going to prefer the multiple bar chart only. So for the division first we got 20%, 20 people are there, so I have to construct this bar, and for the division 2 I have to construct 30, and for division 3 I'm going to construct 30, and for failing it should be 15, and for the result of it should be. So like this I can able to construct the bar diagram. So what are the advantages of this one is that, so visually strong, and then the bar graph displays discrete data in separate columns, and should also estimate the key values at gallons, and summarize the large data set into visual form, and then which can also permit visual check of the accuracy. So the advantages should be very useful by seeing this bar diagram, like very strong, visually strong representation, and so the bar graph discrete mainly used for not for continuous data, it is going to be used for only discrete data, and the key value estimate the key values at a glance it can able to show, and then it can also show large data set in the simple visual form, and which can also permit a visual check of accuracy. So when it comes to disadvantages, so this graph can be recorded to emphasize certain effects, and then which can also record additional written or verbal explanation, and then which can also be manipulated easily to yield a falsy impressions and be adequate to describe the attribute and behavior. So these are the disadvantages of that. Okay, so it can able to require additional written and then manipulated to yield the false impressions and be adequate to describe the attribute and then behavior. Comparative bar diagram, so is another type of bar diagram. So which is going to be shown the parallel bars or variable lengths to illustrate the comparative cause exposed birth rate. So advantage is that which can also be compared 2 and 3 data sets at a time. So for the division 1, so if I'm going to show how many number of males and how many number of females. For division 2, how many number of males, how many number of females. For division 3, how many number of males and how many number of females like this. This type of presentation I can able to show very easily. So I can able to show this comparative bar diagram in either in horizontally or vertically. So just now I said right. So for division one, how many number of boys and girls I want to show. So for the division one, so I can able to show the difference between first thing two attributes. If I want to show simultaneously, then I have to go for the bar diagram. So histogram. So histogram is the other kind of graph what we are going to have, and which can able to show the continuous data here. The ordered columns and the categories on the continuous measures such as time, inches, and the temperature. This histogram normally displays the continuous in ordered way only, and such as time, inches, and temperature. So if you look at this histogram, so normally the bar diagram. So this should be the histogram. So histogram is the thing we can obtain from the bar graph itself, but we should not maintain any kind of graph between them. So, but we are going to represent the bars in between the class intervals here. Okay, so it is if I am going to consider the class interval, then it should be histogram is the perfect thing. So in between the 60 to 65 and 65 to 60 to 65 and 50 to 55, 45 to 50, 40 to 45, 35 to 40 like this. In between the class interval, if I want to show how many number of females are there, there should be 3 and there should be 5 like this. So I have to construct the histogram in the single fashion. So this is the way of constructing the histogram. So it should looks like a bar diagram, but they should not maintain any kind of space between them. And mainly this one is going to be constructed based on the frequencies only. So advantages. So advantages should be it should be visually strong, and then should also be compared to the normal curve. And usually vertical axis is the frequency count of items falling into each category. So these are the advantages of the histogram. So histogram also visually strong, and then it can also be compared to normal curve. And usually this vertical axis is going to be used for the frequency count of items into each category. And disadvantages is that so which can also be you cannot read the exact values what it should be since we are going to be group the items and more difficult to compare the data sets and usual use only with the continuous data is not be suitable for the discrete data. Okay, so for the continuous data only this histogram is going to be used here. And frequency polygon it is another kind of representation, so normally this one is going to be obtained from the histogram only. Frequency curve and frequency polygon. So what is the difference between frequency curve and frequency polygon? So here once we construct the histogram, so after joining the midpoints of all the bars what I obtain here, so if I'm going to join like this, then it should be a frequency curve. If it is joined by line, then it should be frequency polygon. Suppose the same thing what I am going to be joined with a smooth curve like this, so then it should be frequency curve. So the frequency polygon can be obtained after drawing the histogram. So in that way, and frequency curve it should be of this one. That should be frequency curve. So how to construct this? Let's see the interval. So you also have to take the class interval here, and then in between the class interval 4 to 5, how many number of people? 5 is there. Let it be. So draw it and again draw it, and draw the 9 in between the class interval 8 to 9. There should be 3. So after joining the midpoints of all the curve with a straight line, then it should be a frequency polygon. Okay. So what is the advantages of this one? So visually it should be appealing is the only advantage. When it comes to disadvantage, so the anchors at the both ends may imply 0 as the data points and usually use only with the continuous data. So the frequency polygon should be only used for the continuous data only, and visually appealing should be the advantage. And cumulative frequency polygon. So that means that here we're going to calculate the cumulative frequency distribution, which one also called as OGU, and which is going to be used to determine how many or what proportion of data values are below or above a certain value if I want to find it out. So for that we have to make use of cumulative frequency polygon. So cumulative frequency polygon is the thing which is used to determine in how many or what proportion of data values are below or above a certain value. Okay, so the cumulative frequency is the thing. So after constructing this, we have to be draw the relative frequencies after the class interval. Let me show that. So see here. This is the class interval I'm taking. So 20, 25, 25 to 30, 30, 35. And this should be the frequency of values of what particular class interval. So for this, I have to find out the cumulative frequency. How the cumulative frequency is going to be obtained. So initially, I'm going to have 2, right? So for this 2 plus 2, how much? 2, 6. Sorry, it should be 4 here. Let it be 6. So 4 it should be. So 2 plus 2, let it be 6 here, cumulative frequency. Initially frequency is 4. So after adding 2, I'm able to this. Again 6 plus 2, 8. If it is 9, 1. So 8 plus 16, 17. 17 plus 12, 29. 29 plus 14, 43. 43 plus 1, 53. 53 plus 16. So like this, I have to calculate the cumulative frequency. From the cumulative frequency only, we have to construct the OGI graph. That should be cumulative frequency curve. But so how it should be? Then between the class interval, this should be the graph, right? Let it be. It should be 2 here, and next one should be this, and next one should be this, and next one should be this. And next one should be this. So this should be the middle points of the each bar curve. Okay. So after joining all the midpoints of the rectangle bars from the histogram, so after eliminating all this, what I'm getting should be the frequency curve. That is what we call as OQ. So normally this diagram should be more attractive and well proportioned with the neat and pleasant to the eyes. And the graphical forms make it possible easily to draw, visually makes the impression of the data, and this graphical representation should also be enhance our understandings and makes comparison easily, and then which can also make create an impression in the mind of period of time, and then they should be geometrically accurate. So this is the conclusion I can able to make from this data presentation. That means the diagram model should be very attractive one and well proportioned and neatly can able to see and pleasant to the eyes. So the graphical forms make is possible to draw on the visual impressions of the data, and the graphical presentation of data enhances our understandings and then can also make comparison easily. And this kind of method can able to create an imprint on mind for a long period of time, and then should also be geometrically accurate. Okay. So that should be about the data presentation of the data. So advantages and disadvantages. So the graphical presentation of data, that means since the data what I'm get it should be of from multiple sources and convert into table and then represent it. So for that graphical presentation of data, the main purpose should be in order to make the comparisons. So comparing categorical data in the text should be to tables should be something difficult. So what is the main purpose of this data presentation means that we should be able to compare the data, and which can also be compare the series of data over the time, and which can also make the total comparison in the form of percentage and relationship between the two variables. I can able to find it out, and the relation between two or three variables can also be find it out. There are different types of graphical presentation. So just know what I said. That should be pie diagram, bar diagram, compared to bar diagram, and up to here this should be for this set of data will be for discrete data, and last set of three will be for continuous data. Okay, so the bar diagram, so which is going to be show the percentage of data, and bar diagram, so will be of different types, simple, multiple, and composite based on the variables I'm going to take. So if it is a single variable, then I have to go for simple bar. If it is multiple variable, then it should be multiple bar. And composite bar means where the rectangle bar is going to be divided into different sections. And histogram is the thing where you can able to use it for frequency distributions, and remove cumulative frequency distribution can able for OGA. So pie diagram. So normally just know what I said, that should be useful for representing the data. So advantages is that visually appealing, and which can also be summarize the large data into visual form, and we can able to visually simpler than other types of graphs. And disadvantage is that we should know no exact numerical data is going to present, and it is going to be hard to compare the two data sets, and totally unknown unless specified it and useful only for discrete data. Bar diagram. So which is going to be used normally shows the number of proportion of normal ordinal data, and so this view of this bar diagram will be like where you can able to take for the particular variable how to construct the bar, and advantages and disadvantages. So advantages should be visually strong, and then it can able to display discrete data, and then can also be show estimate key value at glance, and then can also summarize the large data set in the visual form, and should also be permit check of accuracy. So when compared to the disadvantages, but it should not be emphasize the certain effects, and requires additional written and verbal explanation is going to be need, and be easily manipulated to be yields from false impressions, and it should be also inadequate to describe the data attribute and behavior. So the comparative bar diagram is the thing which is going to be show the parallel uh, bars of variable lengths, but the advantages is that we can able to easily compare that. So this should be the particular variable for that different characteristic. If I want to use, then I have to go for the comparative bar diagram. And histogram is the thing which is going to be display the continuous data, and this one is going to be constructed based on the class intervals only. So so advantage should be it should be really strong, and then can also make compare normal curve. And disadvantage should not be create the exact values and more difficult to compare two data sets, and use only with the continuous data. So frequency polygon is the thing which is going to be made from line graph, and which is going to be drawn from the histogram only. So this one is going to be obtained by joining the midpoints of the each rectangle bar. So the draw line what is joined through this is should be frequency polygon. And similarly, if the points are going to be joined by smooth hand curve, what I'm going to get like this. So that should be frequency curve, frequency point. So visually appealing. So the disadvantage is that it should only works with the continuous data. And the cumulative frequency that polygon which is going to obtain, so by based on conducting the cumulative frequencies. So after finding it out half of this frequency from the class interval, you have to find it on the cumulative frequency. So how the cumulative frequency is going to be get? So 2 initially, so add the frequency 8 and then 8 plus 9 17, 17 plus 12 29, 29 plus 14 43, 43 plus 53, 53 plus 8 460. So like this I have to calculate the cumulative frequencies. And this is the conclusion I draw, and these are the references. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.